Okay, all right. The online students, can you confirm whether I'm audible? Okay, right. Okay, it seems students are still joining in, but I'll start. Yeah, for Zoom chat, I'll be putting the tune now, so you can download it from there, and for you, you'll get the hard copy. And for YouTube students also, I have pinned a message in YouTube chat with a link, so that navigates you to the tune. Right. For Zoom students, give me a minute. I'll put it in the Zoom chat as well. All right. For Zoom students also, I have put it the chat, so you can navigate to that link and get it downloaded and be ready. Right. Please download it and get ready. So I'll start in 2 minutes. I'll start in 2 minutes. So you can download and get ready. I'll start in 2 minutes. It seems students are still joining in. So meanwhile, you can download. Okay, all right. So good morning, everyone, again. And as we planned, today we'll be starting mechanics. That's a milestone lesson because we are moving on to our unit 2 in our syllabus. And when it comes to mechanics, mechanics is the largest lesson in our syllabus as well. Right? So first I'll explain the gravity of the lesson, mechanics, and then I'll be moving on to the parts that we are going to start. Right? Because now in first month we have our unit one. In unit one we did measurements. In there we have our units, dimensions, and measuring instruments. Right? And now since unit one is finished, so last day also we had the traveling microscope. That was the last measuring instrument. Now the unit one is finished, and now we are moving on to our unit two. And when it comes to unit two, this is unlike unit one. Unit one is actually just a very small lesson, and you can get some background, and you can just play around with the units, those things. And this is where the actual physics here in A levels are going to start. Right? This is where you are going to see uh, the gravity of actual physics here. By the by a unit like units, dimensions, and measuring instruments, you don't see that depth, right? Because that is how it is. That is just to make you comfortable around the subject and make you comfortable around the things we are going to do in physics, right? So this is where we are going to see. You are going to see the real depth of the subject. This is just the start, right? And from mechanics onwards, in all other 10 units coming now, you will see that actual depth of the subject, right? Okay. So first I will explain the gravity of mechanics. Right. So first I'll explain the gravity of the lesson mechanics. Right. When it comes to mechanics, the gravity in the sense, first let's see how we are going to get questions from this unit mechanics. Right. You all know that our physics paper consists of two main papers, paper 1 and paper 2. Right. So we have paper 1 and paper 2. Paper 1 and paper 2. Paper 1 is paper with 50 MCQs. Right? So this is with 50 MCQs. This is MCQs. Right? And when it comes to mechanics, from mechanics, 8 to 10 MCQs are coming. So it contributes for 8 to 10 MCQs. Out of 50, it contributes for 8 to 10 MCQs. Right? And when it comes to paper 2, it consists of two main parts as structured essays and essays. As structured essays and essays. Right? From mechanics, a definite one structured essay is coming. And a definite one essay question is coming. Right? Now, if I compare this with the unit 1 measurements, from measurements only one MCQ is coming. Only one MCQ, and there is no definite structured essay. They ask probability of having essay from unit 1. No essay questions. That is unit 1. From unit 2, mechanics, 8 to 10 MCQs are coming. 8 to 10. Least 8, or minimum 8, maximum 10 MCQs. And the definite structured essay is there, and the essay question is there. And if I convert this to mark, the allocation of mark, 8 to 10 MCQs means, say 10 MCQs, that is 10 marks. Always 1 MCQ stands for 1 mark. And one structured essay is for 20 marks. And one essay is for 30 marks. And the mark here in the second paper is given out of 200. Therefore, these marks are going to be divided by 4. So, as final mark, here you will get 5. And from here, you will get 7.5. And from here, this 10 is a final mark because the MCQ paper contributes for 50 marks from 50 MCQs. And now, if you add up all 10 plus 5 plus 7.5, this is 22.5. So, this is 22.5 from 100 down. From 100, this is 22.5. Right? So, basically, we call this as a 20% lesson. The reason is when it comes to physics, remaining 10 units in physics, right, we have a classification called 10% and 20% units. Right? So this is one of the 20% lesson we have is actually just more than 20%. Right? This is one of the 20% lessons we have. Mechanics. So this is the gravity. This is the gravity. And the other thing is, from mechanics, all these parts in mechanics are linked to all other coming up units in the syllabus. Right? Everything is linked. Everything is linked. Mechanics is the lesson we have with the highest number of links. Highest number of links means it is linked to all other units coming up. Very simple as that. Very simple as that. Right? So therefore, starting from today, grab everything properly, start getting everything properly because we will be starting from scratch, from very scratch, from A to Z we will be discussing. So be in the live class, and get everything from the beginning. And here there's a flow. Since there's a flow, now if you miss the first day, now this first day is going to be connected with second day. Right? And the second day is going to be first 2 days are going to be connected with third day. So likewise, the flow is there. Right? A complete flow is there. So therefore, in mechanics, even if you miss one lesson, even if you miss 1 day of the class, the impact is not going to be like insignificant. That is a very significant impact. Right? So therefore, starting from today, grab everything from scratch and grab everything and work hard here in mechanics because the reason is this is the most critical lesson we have here in our syllabus. Right? Most critical lesson, and we are starting it kind of before compared to the other classes. Right? We are kind of ahead compared to other classes. If you can get aware, now still the other classes are doing measuring instruments now. So since we started just after O levels, right, just after the week of O levels, now we have pick up some phase. Right? So with that, now we are moving on. So emphasizing again, this is the lesson we have, this is the unit we have with the highest number of links. Right? So since it's having the highest number of links, it's the most critical lesson, it's the most critical unit we have in our syllabus. Right? So therefore, don't miss any classes and always stay in the live classes and get everything from zero here. Right? Then you won't break that flow. Once that flow is there, you can easily build this up until the very end of mechanics. That is how it is going to be connected. Everything in mechanics is connected itself, and mechanics is connected to, it's linked to all of the units. That's the beauty. It's the beauty of mechanics. Right? Okay. Any questions? Any questions or anything to clarify? Any questions or anything to clarify? All good? All good? All good? Okay. So have some idea about this. Have some idea on this. And now if you need to take this down, you can take this down. I mean, not in the note, but as a rough work. You can take this down if needed. What I have to say is you have to have an idea of this. Because when you study, you have to know mark reservation you are going to get in the exam. Right? So then only you know the gravity of the lesson. You know the magnitude of the lesson. Right? That's the thing. Right. Okay. Then we'll start. Put the as mechanics. And repeating again, repeating again for registered online students, can you confirm me whether you have got the you have got the registered students and the students who join today for the seminar, you will get the soft copy of the tube. And for some students, I have put that link to the chat box of Zoom. And for the students who are on YouTube, I have pinned a message on the chat. Registered online students, can you confirm whether you have got the tube by now? Quickly. Some says yes, some says no. If you didn't get it yet, within today or maybe tomorrow you'll get, because I think the probable reason is we had a holiday in between them, right? Tubes were posted as usual, but since we had the polar day on Tuesday, we had a polar day. So with that, sometimes it is probable to have a delay, probable to experience a delay. Sometimes it might be a reason. Sometimes it might be a reason, right? So if you didn't get, you can download it, download the soft copy, and be ready. But sooner you will get it. The registered students, sooner you will get it. To the address you have entered in the LMS. Right. Okay. Put that in as mechanics. Put that in mechanics. And especially online students, be comfortable with yourself before starting the session. Don't try to leave the device, laptop or mobile phone or whatever you are using during the class, because here when it comes to mechanics, each and everything is very critical. So therefore, uh, prepare yourself, and if you need board or something, you can have it nearby. So likewise, try to stay these 3 hours. Try to means you have to stay. You have to stay these 3 hours time focusing to the class, right? Especially for online students, right? So when it comes to mechanics, in mechanics we have several subheadings going on, right? So today we will be starting the first subheading under mechanics. Write down linear motion. Linear motion. This is the first subheading under mechanics. So we are starting with linear motion. Write down linear motion. Take down the heading linear motion. Linear motion. Right. So first tell me if you have any kind of an idea about a linear motion. What's the thought you have about a linear motion? What a linear motion is? What thought you have about a linear motion? Right? So anyone can engage, right? Anyone can engage. You are online student, you can engage yourself by putting answers to the chat box, right? So what's a linear motion? According to your thoughts. What's linear motion according to your thoughts? We're going to go to that row. Motion that goes on a straight path to an area on a linear path. What's a linear motion? We just started, right? So before that, I was explaining about the gravity of the mechanics, gravity and the magnitude of mechanics, right? So will you be able to share the PDF? So I could not be able to download as I don't have Telegram. Can you drop me a private message? Can you drop me a private message? Right. Yeah. So I got few correct answers. Yes, that is correct. So simply, a linear motion is a motion it undergoes in a straight line, or we can say a linear path, right? So simply, if any object undergoes in a straight line, it doesn't matter how it undergoes, like with uniform velocity or with an acceleration or deceleration, doesn't matter as long as it undergoes in a linear path, right? A straight line, that's called a linear motion. That's called a linear motion, right? So that's a simple idea, and for you to get some idea, we have 6 motions altogether in our syllabus. 6 types of motions, and linear motion is the very first type of motion we are studying. That is actually the simplest type of motion we are studying, right? And just know that there are 5 more types coming up about motions. 5 more types of motions, right? Okay. So on the linear motion, put some asterisk mark and write down. Put an asterisk mark and write down. No, not in red. Right? Put an asterisk mark and write down. If an object, if an object, if an object travels along, if an object travels along, if an object travels along a straight line, an object travels along a straight line slash linear path slash linear path. It is called a linear motion. 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 Right. Listen. Now, to study about linear motion, right, we have several parameters. We call them parameters. Have you heard the word before? Parameters. Parameters. No. Right? Parameters are, you have heard. You don't know the meaning. Don't know the meaning. I've heard. Yeah. I remember. Right. Parameters are simply the variables. Parameters are the variables. Right. So parameters are the variables, and those are the things we need to look at when we study about the motion. Now, as an example, or even though you don't know the parameters, you know variables. Right. Now, when it comes to linear motion, linear displacement is a variable. Initial velocity is a variable. Final velocity is a variable. Accelerations are going to be variables. Time is going to be a variable. Likewise, those things are parameters. I mean, all levels also you have done these things, maybe variables. But now you are mature students, now you are doing A levels, A level physics. So now you have to use the word parameters. So if you are doing combined maths also, you will get the same word, parameters. So we call them parameters. Right? We call them parameters. So basically, we have 5 parameters to study linear motion. We have 5 parameters to study about linear motion, 5 parameters to observe linear motion. Right? So those are the parameters we are going to measure and use to explain, to describe linear motion. Is that clear? Right? So as a subheading, write down parameters of a linear motion. Parameters of linear motion. Parameters of linear motion. Parameters of linear motion. Parameters. This is how it comes. Parameters. 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 Okay. So we have 5 parameters. Don't talk. 5 parameters. Write down one by one. Okay. First one, linear displacement. The reason to say this as linear displacement is we have some other types of displacements as well coming up as angular displacements, right? So we have other types. Now in all levels you might have get used to displacement, but here we have to be specific as linear displacement, right? Linear displacement, because the respective displacement of a linear motion is a linear, right? Linear displacement. And second parameter, initial velocity. Initial velocity. And the next parameter, final velocity. And the next, linear acceleration. Linear acceleration. The reason to say a linear acceleration is there are some other types of accelerations as well. Right? There are types of accelerations. And last but not least, time. Right? So basically, these 5 are the parameters we are going to have to describe about a linear motion. To describe a linear motion. To describe about a linear motion. Right? These are the parameters. Now, for these parameters, we have standard labelings. Right? So it goes as this. Linear displacement is denoted by S. Initial velocity is by U. final velocity is by v, linear acceleration, simple a, and time, simple t. Write it down. Write it down. Variables. Variables are the things which changes with the motion. Right? Now, if time changes with the motion, if velocity changes, velocity is a variable. Variables are the things they change in the motion throughout the motion. Right? Okay. Now, listen. Based on these parameters, based on these parameters, we have four linear motion equations to study this linear motion. Right? And when it comes to these four linear motion equations, we don't have the proof of these four equations here in physics. Right? But all these four equations will be proved if you are doing complements in complements. In linear motion, these four equations will be proved. In physics, we don't have the proof of the equations. We have to use the equations and do these applications. Right? Okay. Now, as an next thing, write down linear motion equations. 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 Right. Don't write, just look at the board. Don't write, just look at the board. Right. From here, some equations you might have already know. Right. First one, V equals U plus AD. One of the linear motion equations. Right. Second one, S equals UT plus half AT squared. S equals UT plus half AT squared. Next, V squared equals U squared plus 2AS. And the last, S equals V plus U over 2 all things times T. So these four are called linear motion equations. These four are called linear motion equations. Right? So actually we have only four linear motion equations. These are the four linear motion equations. Right? Now, these variables are used in the equations. So which means by using these equations, we can model linear motion. We can describe linear motion and we can find relevant details if required by using these equations about the linear motion. So that is what the whole purpose behind this. Right? So given by these variables, given by these parameters, we have these four equations. These are called linear motion equations. These are called linear motion equations. Right? Okay. Now take this down and highlight all four equations. Take it down and highlight all four equations. SC is a capital letter. Yes. We both are in, that doesn't matter. Not critical. Both are in. And for S also, even if you write simple S, that doesn't matter. Usually it's capital S. Please. Stay down. Okay, finish. Okay. The introduction of these terms are already here. So therefore, I'm not going to introduce these terms again. Here, variable in the equation. They are the parameters. Right? So introduction of the terms are here itself. Right? Okay. Now, listen. The very important things when using these equations are all these four equations are vector equations. Vector equations means now their variables are vectors, no? Except time, all other variables are vectors. Time is a scale. Time is a scalar quantity. All other variables are vectors. So therefore, they are vector equations. In left hand side also it has vectors. In right hand side of the equation also it has vectors. Right? Therefore, no vectors. Yes. Right? Therefore, we can only apply this equation along considered direction because vectors are the physical quantities with the magnitude and direction. So we can't apply these equations as we wish, right? In each direction or in every direction. Right? Along the considered direction only we can apply. And when doing so, there are some other basic rules regarding vectors also to be followed here. Right? Okay. Using a red pen, write down. Using a red pen, write down. Using a red pen, write down. Put an asterisk mark and write down. All linear motion equations are. All linear motion equations are. All linear motion equations are. All linear motion equations are vector equations. All linear motion equations are vector equations. All linear motion equations are vector equations. Next point. Therefore, all equations should be applied. Therefore, all equations should be applied. Therefore, all equations should be applied along a considered direction only. 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 Right. Now look at the board again. Look at the board again. Look at the board again. Now, there are few basic vector rules, regarding vectors that we need to follow. Now we have to have a considered direction. We have to have a considered direction to at the board. We have to have a considered direction to apply these equations. A considered direction. So if we have vectors acting to the same direction, such vectors are considered as positive vectors. If we have vectors to the opposite direction of considered direction, such vectors are considered as negative vectors. Right? And if we have any vectors which are perpendicular to the direction of consideration, they are neglected. Right? And if we have any inclined vectors like this, inclined, not perpendicular, not parallel, they are inclined. Right? So if you have inclined vectors like this, they have to be dissolved and this dissolving is not going to be involved here in linear motion. But since I need to uh, remind you and recall you about all vector laws, I'm recalling this here. Guys, when it comes to projectile motion only, you will be using dissolved components for the first time. Right? Projectile motion is the next type of motion you are going to have, just a linear motion. Right? So this is dissolving. Right? So these are the four basic rules regarding vectors, and these rules are valid for any type of any type of vector throughout the syllabus. Huh? Now, even if you are doing let's say higher studies on maths, physics, or during some particular field, right? Still the same. So they are not going to be changed hereafter, right? All these four vector rules are valid everywhere and anywhere of the world. That is how it is. They are standards. They are the vector rules, right? Okay. As an next point, write down. As an next point, write down. Keep using red. Keep using red. All basic rules regarding vectors. All basic rules. All basic rules. All basic rules. All basic rules regarding vectors. All basic rules regarding vector should be followed. Should be followed. All basic rules regarding vectors should be followed when using above equations. When using above equations. Right? Consider direction. Consider direction is a freedom we have. So we can consider direction. And that particular consider direction is going to be positive. Right? So if you are considering horizontally right, you are consider direction. Right? So we will see these questions. Or if you are going to consider, let's say, horizontally left, then your consider direction is going to be horizontally left. With respect to that direction, this is defined. Right? Okay. Write down one by one. Use the normal color now. Use the normal color. One by one, write down. First one. First one. All vectors acting along. First one. All vectors. All vectors acting along. All vectors acting along. Along. Consider direction. All vectors acting along consider direction are considered as plus. All vectors acting along considered direction are considered as plus. Are considered as plus. Second one, all vectors acting along. Second one, all vectors acting along. Opposite direction to consider direction. Acting along opposite direction to consider direction. Acting along opposite direction to consider direction are considered as minus. Are considered as minus. Are considered as minus. Third one, vectors acting perpendicular to. Vectors acting perpendicular to. Vectors acting perpendicular to. Vectors acting perpendicular to consider direction. Are considered as are considered as zero, as zero, zero within brackets neglected, within brackets neglected, right? So since the value is zero, we can neglect. That's the idea. Since the value is zero, we can neglect it. And fourth one, the last one, vectors acting, vectors and acting inclined to consider direction, inclined, inclined, vectors acting inclined to consider direction should be dissolved, should be dissolved, should be dissolved into components, 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 right? Okay, so basically, now as a summary, this is what we do. This is how we deal with these vectors. This is what we do. This is how we deal with these vectors. Right? So as a summary, mention this capital form and highlight it. Right? So I'll erase this. So mention the rest. Mention the rest as a summary. Right? The summary of the points I gave there is this. This is the summary. Right? This is the considered direction. Considered direction can be any considered direction, and that freedom is it. We can consider any particular direction with the question. Right? And with respect to that direction, this four is working like this. Right? What should we write as the heading of the part on the right? Linear motion equations. Yes, yes. Right? Linear motion equations. Hey, done. Okay. And if you have any doubts, any questions, you can always raise them. Right? Good. Good. This is a summary of this is a summary of what I said. Right? So you will see how it works. You will see how it works when it comes to the applications. Okay. So any questions, any doubts, any questions up to here? Right? I didn't start any applications yet. Right? This is just an introduction to linear motion with its parameters, equations, and since the equations are vector equations, this is the introduction about the basic rules regarding vectors and vector equations. Right? Okay. All good. Right. Okay. Now we are slightly moving on to few applications and let's see. Right. First, I'll discuss an example with you before moving on to the questions. Right. First, I'll explain an example scenario. Look at the board. Don't write anything, just look at the board. Okay. Look at here. This is an example. Don't write, just look at the board. Don't write. Right? Let's assume, there is an object here. There is an object here. Right? And say this is point A. This is point A. Right? And the object is at rest at this point. So its initial velocity is 0. Right? And it is going to start some motion towards this side. See, it is going to start some motion towards this direction. And after some time, same object is here. So let's say that point as B. Right? So let's say that point as B. Right? And let's say it has gained a velocity at this point. Of 20 ms minus 1. Right? And that is the final velocity 20 ms minus 1. And for this motion from A to B, it consumed some time. Right? So therefore, for any kind of a linear motion, we have to have a point of measuring time. So starting point of the motion, starting point of measuring time is called t equals 0. That is called t equals 0. So starting point. So at here, t equals 0. No time has passed. Right? So at here, some time is passed. So that is called t equals t. That is called t equals t. Right? If you need to get the time interval, final time minus initial time, t minus 0, that is t. The time interval t is consumed here for this motion. Right? Now, if this object has increased its velocity from 0 to 20, that is actually accelerated. Velocity increases. You know, acceleration is rate change of velocity. Rate change of velocity. Right? So if the velocity increases, there is an acceleration. If the velocity decreases, there is a deceleration. Therefore, from here to here, this object has an acceleration. Right? This object has an acceleration. Let's say A. Right? To show you an example calculation, let me assume this time has 5 seconds. Now for this motion, let's assume it has consumed 5 seconds. Right. Now, if I explain the scenario again, an object starts from A equals 0, right? And starts moving towards it or the rightward direction, right? And during 5 seconds of time, it has gained the velocity 10 to the minus 1. That's the scenario, right? Now let's say I need to calculate the acceleration gained by the object. Right? If I need to calculate the acceleration gained by the object, now it is variables. Now u is not, e is not, t is not. It's the use of these variables. You can pick relevant equation from this list, and that's the That's the basic behind this. Now, if I need to get the acceleration, now displacement is unknown, so I can't use any equations with the displacement because displacement is unknown. We don't know the displacement yet. So therefore, in this equation, we have final velocity, initial velocity, acceleration and time. Initial velocity is 0, 0 means that is known. Final velocity is 20, 20 means that is known. And initial velocity is 0, which means that is known. Final velocity is 20, which means there is not. Time is 5 seconds. There is not. What I need is acceleration. Right? So easily we can use V equals U plus AD. Now, this is where the vector basics or basic rules regarding vectors comes. Look at the board. Don't write anything. Equation is V equals U plus AD. This is a vector equation. Now, if I am using this equation considering this motion, direction of motion is I equal to I equal. Therefore, it is easy for us to consider the moving direction as the applied direction. The reason is then we can consider those vectors which are acting along that same direction as possible. Now, otherwise, now we have to really consider as now if I consider my direction respectively, these variables are going to be everywhere. Same answer comes. Because with respect to my considered direction, the application changes. So that is how the same answer comes. Right? But basically, and usually, we will be applying the equation to the same direction of motion. Because we don't need to have unnecessary negative signs in the equation. Right? Likewise, this has to be mentioned. This is a must. The direction should be mentioned because it's a vector equation. For all vector equations, the direction is a must. Okay. Now, look at here. Look at here. Point A is my starting point now. That is the initial point. Point B is my final point. That is the final point. So therefore, initial velocity refers to velocity is at initial point. And final velocity refers to velocity is at final point. Now I'm considering from A to B. Direction is this from A to B. So likewise, this has to be mentioned before applying the equation. Horizontally rightwards from A to B. Right? This is called a section. This is called a section. Right? So listen carefully because there are some jargon to be get used to, some words, technical terms to be get used to. Right? This is called a section. Right? From A to B. So starting point of the section is the initial point. Final point of the section is the section. The section is the final point. Right. Now, final velocity should be the velocity at B, point of the section, 20. And that is in the same direction, so that is a plus 20. Plus 20. Right? And U is the initial velocity, initial point is here, U is 0. Plus A is what we need, times T is 5 seconds, 5 minus 0 is 5. So time interval is, or we can simplify this simply. 20 equals 5A. So acceleration equals 4 ms minus 2. So the acceleration of the object it has is 4 ms minus 2. Right? So likewise, now I can explain. Now I know about the acceleration of the motion as well. Now I can explain the motion with acceleration as well. And so hereafter, I show you how to determine the displacement. Now, knowing few variables, all variables can be determined. Knowing few variables, knowing enough variables, all other variables can be determined. Now, acceleration is known. Right? And next, we will see how we can determine the displacement. Right. First, as an example, take this down and write down. As an example, write down. Let's consider. Write down. As an example, write down. Let's consider. Let's consider. Let's consider. Let's consider an object travels from. Let's consider an object travels from. Let's consider an object travels from A to B. Let's consider an object travels from A to B. Okay, put a comma and take this down and start writing down from here, right? And finally determine this acceleration. Only 4 linear motion equations. Yes, there are many. There are around 120 equations. We have mentioned the considered direction. Considered means we are considering. Considered means we can consider. Right? Considered direction is a freedom we have. Right we have. With respect to that, we have a equation. Right? But always using the direction of motion as considered direction is easy. Because we can write more positive vectors. And otherwise, we are going to have unnecessary negative signs. Otherwise, there is no any rule. The rule of thumb is apparently direction of motion. That's not a rule. That's a rule of thumb. All right, take down quickly. Take down. Questions? Any questions? Any doubts? If you have any doubts, you can ask. Finish? Okay. Now, look at the board again. Look at the board again. Now, let's say I need to determine the displacement. Fine. If I need to determine the displacement, I'm erasing these equations. Erasing the equations. Now, if I need to get the displacement, now what we can do is, now with the availability of data, now you can pick an equation. With the availability of data, you can pick an equation and apply. Right? Now, since all initial velocity, final velocity, acceleration, time, now there are multiple options available. Right? S equals UD plus half AD square can be used. Right? Or else if needed, A square equals U square plus 2AS can be used. Right? Multiple options are available. All other equations can be used to determine displacement. Right? Multiple options are available. From all the equations, you will get the same. You will get the same. Right? So I'll show you two methods. Two methods. First method is you can use S equals UD plus here. Again, you have to mention these two are very important. Direction and the section. Right? You can write words from A to B. Equation is S equals UD plus half AD square. S equals UD plus half AD square. Right? SC is going to be measured from here to here. SC is measured from here to here. This is what we are going to calculate. This is what we are going to calculate. Displacement is measured from A to B. Right? So displacement U is 0. 0 times 5. 0 times anything is 0. Plus of acceleration to the same direction is 4. T squared is 5 square. This is the substitution. This is the substitution. Now simplify. Simplify and see. S equals, this is 0. And from here, can you see these 2 cancels? This 2 to 4 cancels. Right? 2 times 5 squared is 25. So displacement is 50 meters. So during these 5 seconds, this object has moved 50 meters. The object has moved a displacement of 50 meters. That's the whole idea. That's the whole idea here. Right? Take it down. I'm explaining an example here. So if you have any questions, please raise them and get it clarified. Not a must, but if you make sure that you don't mistake it with 5, that's it. Right? Now, as an alternative, if needed, see, as an alternative, we can use another equation from A to B, like this A squared equals U squared plus 2A's. Right? B squared is 20 squared. 20 squared. U squared is 0. 0 squared is 0 plus 2. A is 4. S 2S. Right? So this is 20 squared is 20 times 20. No? Without writing 400, I'm writing it as 20 times 20. Right? And this is 2 times 4 times S. Now you can cancel this. This is 2 times 10 and this is 4 times 5. Right? So 5 times 10 is equals 50 meters. So either way, you will get the same. As long as your application is proper, as long as your application is correct, you will get the same. Right? Now in this case, there are multiple options available. And even if you apply the last equation, S equals E plus U over 2 into T, still you will get the same. Right? So this is how linear motion equation should be used. This is how linear motion equation should be used. Right? This is how it should be used. So get this idea. Get this idea. Now we are starting applications now, right? So actually, just after this one, this example, we are going to start applications one by one, and starting from the simple application, and we will be going towards the complex ones, advanced ones, right? So grab it from here. Grab it from here. Get this idea. Get this idea. This is how you should apply the linear motion equation, right? And make sure these things are direction, section, and the equation. Now, when it comes to essay questions, you have a separate mark allocation for this part for direction, section, and the equation. Right? So that is how it's that's how it's critical it is, because they are vector equations. Right? So any vector equation, that mark allocation is there always for the direction you are giving marks. In arrows, using arrows. Yes, must. It's a must, right? So that's why I am emphasizing it is a must to mention the direction and section. So start it from here. Make sure that you are starting from here, because in O levels you don't have to be this much critical on these things, right? You are just applying an equation, getting it done. That is how it works in O levels, right? But when it comes to here, right, that is very much critical, right? Very much critical. So starting from here, Make it a habit today onwards. You have to mention direction and section. That's a must. Right? Hope it's clear. Clear enough, right? Okay. So let's move on. Let's move on. Go to go to uh, go to first page of the route. Go to first. Go to first page of the route. Go to first page of the route. First page. First page of the route. And see question one. Go to first page of the route and see question one. And listen before starting the question. And starting from the first question onwards, always make a habit of drawing a sketch diagram like this. What sketch? The reason is in the coming up parts, when moving towards complex questions, for the same motion, you will be having different sections. Right? And the questions are going to be linear. So therefore, the purpose of this sketch diagram is we are extracting all the data given with the description and mentioning it here because then again we don't need to go to the just by looking at sections and the details, the information given in the diagram here, we can deal with the modeling. That's important. So this is called a sketch. Right? No need to have a nice and like beautiful diagrams here. The most important things are the given data. No? So make sure you are mentioning these given data properly. That's the purpose. That's the purpose. Right? So starting from the first one, get used to the sketch as well. So I'll be helping you out because this is the first one. So what you can do is you can read the question first and start trying it. So you can start trying now. Question 1. An object charged motion at rest and gain a velocity 10 mm minus 1 within 4 seconds. Determine its acceleration. So start the habit from here of drawing the sketch, draw the sketch, and start your thing. And make sure mandatory things, must do things are done in your calculation, like direction and section. For online students who didn't receive the hard copy of the dude yet, so what you can do is you can download the soft copy and do things today here, and you will receive the hard copy soon. As I told you before, I think the in between day is a probable reason for a delay. Right? It might be a reason. Otherwise, it should be received by Wednesday. Usually, that is how it works. Sorry, reason. Are you doing it? Right? Okay. So first thing is sketch. This is the question one in tube. Question one. Right. An object starts more than at rest and gain a velocity of 10 ms minus 1. Right. So I have a small sketch. Right. An object starts more than at rest, which means u equals 0. And it has gained a velocity. Mark it with the direction 10 ms minus 1. Right. For our ease and for we to identify the section, you can use any letters, A, B, C, D, O, X, Y, Z, anything. That is for you. You have to use any letter. Be labeling as A and D. And this is my D equals 0. D equals 0 starting point of time, and D equals T is the last point of or the final point of measuring time. Now T is given as 4 seconds, which means this T equals 4. At once we can measure it as T equals 4. Right. Now the acceleration is also from here to here. Now usually when we mark acceleration, we use multiple factors to easily distinguish between velocity and acceleration. For velocity, we use single letter arrow, and for acceleration, multiple letter arrows. Right? Not the rule, but for us to easily identify. Right? Okay. Now this is how it should be. Are the answers to the 2 and 5? Right? Others? Online students? Is that the same? Online students? I hope you have got answers. Right? Right? So now, write words from A to B. Right? So the equation is U is known, V is known, T is known. So then we can use V equals U plus AD. V is 10, U 0, right? Plus A times T is 4, right? So then equals 4A, simplify this, A equals 2.5 ms minus 2, putting unit in the final answer is must, right? If you miss the unit in the final answer, no marks will be given for the final answer. That is how strict that is. That is how strict that is. It is strict. Without units, you won't be getting any mark just for the correct number. 2.5 is minus 2. Yes, good. Yes. On the answer sheet, wherever you are doing the question, or even for MCQ, sometimes you might need to draw a sketch, even if there is a MCQ sketch, there are some questions that we can't imagine without this sketch, right? That's why the practice is needed. Okay. Any questions? All good? Okay, let's try another one. Go to question 2. Right, go to question 2. Question 2 of the tube. Go to question 2 of the tube. Question 2 of the tube. It says an object is released at rest under gravity. Under gravity means, look at here. Determine its velocity and what's the polarity. Right. 2 questions are asked. Anything released under gravity means something like this. Right. So let's say this is the object I am going to release. Right. Releasing under gravity means it's releasing under gravitational acceleration. Right. So once this is released, it is coming downwards. The reason is we have gravitational acceleration acting very downwards. And gravitational acceleration is the natural acceleration of Earth. Right? If the planet changes, it changes. If not, it remains same. At any point of the Earth's surface, gravitational acceleration remains same. So as a label, we call it as G, has a value. We call gravitational acceleration G. The value is considered as 10 ms minus 2 for calculations. Otherwise, the actual value is 9.81. For calculations, we will be considering it as 10. Right? Gravitational acceleration is the natural acceleration we have to the surface. That's it. Now, if you are on the moon, it is different. Acceleration on moon is different. Gravitational acceleration on moon is different. Now, this is gravitational acceleration on Earth. So, if we release any object like this under gravity, that is why it comes downwards naturally. Now, doing anything, it comes down because of the gravitational acceleration. Right? So, this scenario is also similar scenario. It says an object is released under gravity. Something like this. Release at rest means releasing from zero velocity. Right? Releasing from rest. Rest. No motion. Rest means no motion. Releasing from zero velocity. Under gravity. So if we release under gravity, what happens is the motion is going to be vertical downwards. Right? The first thing is the sketch. Motion is going to be vertically downwards. Right? Now, if I consider an object like this, right? So let's acceleration throughout the motion is gravitational acceleration. We denote it by G. We denote it by G. Right? So this is the simple sketch unit. This is simple sketch unit. Right? And what is asked is determine velocity after 4 seconds of 4. Okay. Time is given. So which means this is t equals 0. And this is t equals 4 seconds. T equals 0 and t equals 4. Right? And there are two questions, two parts. Velocity of ball after 4 seconds of 4. Velocity. Now, if it is moving downward, the direction of velocity is downward. Right? If it is moving downward, the direction of velocity is downward. Therefore, velocity at this point has to be downwards. Velocity at this point is downward. Let's say V. Say V. Yeah. And what's the fallen height after 4 seconds? Fallen height is now it starts the motion at A, now it's the motion at B. The fallen height is the height from here to here. Fallen height is the height from here to here. These two are the two things you are going to calculate now. These two are the two things you are going to calculate now. Now, always we can use G as 10. Always, anytime you can use G as 10. Questions? Any questions? You're going to ask something. Right. 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 Online students, ask if you have any questions. Online students also, you can ask if you have any questions. Ask and get it clarified. Get it clarified. As I told you, grab these things from 0 today. 0 today. And you know mechanics means it's like you know everything about physics because mechanics is connected to area. Right? If you are fluent in mechanics, which means you can grab all other things easily in physics because it's like you know everything in physics because it's easy link. It is having the most number of links and it is linked to other units coming up. Right? So that is why mechanics is being a frontier lesson here. That's the reason. That's the reason. Yes. What's the velocity? Measure the direction and section. Right? Here also. They are very important. Huh? Must do things. Must do things. Velocity. Okay. Yes. Okay. Good. Yes. Answer is correct, but you won't get any marks for the relation. That is how typical it is because first thing you have to mention the direction and the section and the equation. Just know these things, right? These lines are the lines you will be well. First mention each line, reaction and section, and this is the equation. This is called a substitution. For substitution also you have different marks. Basically, this is broken down to four and marks will be given. Reaction, section and the equation, one. And correct substitution. Correct substitution is here, 1 mark. And then simplification, 1 mark. And final answer, 1 mark. So likewise, it is broken down to four and you will be given marks. Right? So those are the things we have to mention. Those are things we have to mention, must mention things. So therefore, just know about those things. Correct? Yeah, correct. And displacement? There are two parts, no? Right? There are two parts. Right? Fallen height. Fallen height is this h. H is a displacement in terms of this motion. Fallen height h. Eight plus 2.5. Yes, it's good. 40. Yes, correct. Good. Correct. Direction and section. Practice it. Practice it. From today onwards, practice it. After some time, after like a week or two, then you will make it a habit, and then automatically you will write directions. Right? Because there is a must-have practice. And if you are doing combined maths, so there are also that same in combined maths. Also, you have vector equations. For all vector equations, these rules are valid. These things are valid. Yes. Right? Height is wrong. Done. Okay. Let's see. Let's see. I'll be raising the first question. Apply an equation. Apply an equation because it is an accelerating object. That is not going to move with the uniform velocity. That is an accelerating object. And its velocity is not 40 ms minus 1, 2 out. That starts from 0. And it's gradually increasing, and finally it has become 40. Okay? Okay. So first we need velocity now. So this is how it should be mentioned. First one, from A to B, downwards, we need velocity now. V equals u plus at. And substitution is B, Q is 0, plus A is G, and G is 10. G can be considered as 10. So that is 10 downwards plus 10 into time is 4. So V equals 40 ms minus 1. Velocity is 40. Right? And if we need the fallen height is a displacement. Fallen height is a displacement. So that is how we should have it. Because in our equations we have displacement. Fallen height is a displacement. Then again from A to B downwards S equals ut plus half at square. You can apply any other equation as well. U is 0, half A is G is 10, and T squared is 4 squared 16. Right? Simplify this. S equals 5 times 16, that is 80 meters. 5 times 6, 16, 80 meters. 5 times 16, that is 80 meters. Right? Understood? From that also you can do. Yeah. Then final velocity is it's known. Didn't you do it? Final velocity is you can use it. Final velocity is 40 no. So plus V as 40. Now if you are using this equation, doesn't matter. You can use it. 40 plus 0 over 2 into 4. You will get the same. You will get the same. So if you have a proper application, definitely you will get the same answer. Right? So if needed, try this way. Because you start that way, that is fine. That is totally fine. Listen, now if you use any other equation different to this, as an example, if you use V squared equal to square from 2a, so it's equal to V plus 2 into B, doesn't matter. If your application is proper, you will get the same answer. Right? Yeah, definitely you will get the same answer if your application is a proper one, is a correct one. Understood? Right? Okay. Use red pen and mention this below the question. Use a red pen and put it right. No? Down of 4 marks. The breakdown is for the direction, section, and the correct equation. This is one evaluation. So that is one breakdown. Right? And this is called the proper substitution. Substitution, plugging values. For that line, another mark. Right? And from substitution to final answer, in between that is called the simplification. For that, another mark. And final answer with correct unit, 1 mark. So basically, any calculation you do, right? Here onwards, in A-level physics, any calculation you do here onwards is broken down to 4 criteria like this. 4 criteria. So you will be evaluated according to that criteria. Now let's say you have mentioned 80 meters, right? Without anything, no marks. No marks at all. Even though that's a final answer, the method is using now, you won't get marks. That is how it is. But let's say your substitution is correct, up to substitution correct, then you will get 2 marks. Likewise. Without the method, if you have just the final answer in an essay question, you won't get any mark. Because the marker knows that without the method, you can't arrive at an answer. No? So therefore, it will be disregarded. Considering that you might have copied from someone or something like that. Right? Right. So with correct pen, mention this. Any object travels under gravity. Any object travels under gravity. Any object travels under gravity. Any object travels under gravity undergoes gravitational acceleration. Undergoes gravitational acceleration within brackets g, simple g. Undergoes gravitational acceleration within brackets simple g. Undergoes gravitational acceleration within brackets simple g. Understood? Listen. Look at the board. Look at here on the board. Look at here. Let's say I'm releasing this object from rest like this. Right? So what's the acceleration it gives? What's the acceleration it has? Gravitational acceleration. 10 m is minus 2. Right? Now, I'm throwing this downwards with an initial velocity, like this. Throwing it downwards with an initial velocity. Without releasing, throwing it downwards with an initial velocity. Now, what can you say about the acceleration it gives? Is it still gravitational acceleration, or is it greater than gravitational acceleration, or is it lesser than gravitational acceleration? If I have given the velocity at this point, like this, I have given the velocity. On next ones, greater. No, that is still the same. That is still the same. Velocity can't change the gravitational acceleration. The reason is gravitational acceleration is the natural acceleration of. So if mass of Earth changes only, gravitational acceleration changes. Otherwise, it doesn't change. Now, with the initial velocity, it starts, but still under the same acceleration. Same acceleration. Only the initial velocity changes. Now, when I apply the velocity here, v is 0. What is the value for u? U is non-zero value. But the gravitational acceleration is same. We can't change gravitational acceleration, and that is the natural acceleration of gravitational field. That is called the gravitational field of Earth. So therefore, just know that because most of the students are mistaking that with if a velocity is given, they are thinking that no, it's the same way. It's the same way. Right? Most of you are thinking that the gravitational acceleration is also going to be increased. No, never, never ever. Right? Because that is with the gravitational field of Earth. If the gravitational field of Earth changes, which means if the mass of Earth changes only, it changes. Unless otherwise, it remains 10 everywhere in this world, the surface of Earth. Is that clear? Right? So if I have applied a velocity here, which means the initial velocity is non-zero. If I'm releasing it from rest, which means initial velocity is 0. If I'm not releasing it from rest, means the velocity is initial velocity is non-zero. Acceleration remains same. Any object under gravity, even if you move upwards, even if you throw upwards, downwards, or in inclined directions like this, inclined directions, right? Same. So any object under gravitational acceleration, right? Same. Just know that any motion under gravity means under this gravitational field of Earth, undergoes gravitational acceleration. Even if you jump from a cliff, right? So let's say you are going to some cliff or somewhere and you are going to jump off, you are going down with gravitational acceleration. And you start your motion from rest, right? So let's say, have you been to World's End in Horton Plains or somewhere else? The famous World's End is at Horton Plains. No? Let's say this is the World's End Horton Plains, and you are here, and you are going to jump off the cliff. So you are starting from 0, and you do your motion under gravity, right? And it is like around 200, 300 meters high, right? So to that 300 meters, you are increasing your velocity. And finally, you are going to hit it down here, definitely you will get hit. If you hit it down here, because now what happens is, let's assume, see, this is 200 meters. Now, the velocity you are hitting the ground is, v square d equals u square plus 2s. See? U square d 0, 2, a is 10, s is 200. Can you see the impact? V square d equals, this is 4000 v square. So v is square root of 4000. Square root of 4000. It's a very high velocity. Square root of 4000 is around, if 100 is still no, 40 means that is around 15 ms minus 1. Right? So with that velocity you are going to hit. Right? So it doesn't matter whether it's this marker or ourselves or whether that is any other object. Any object which travels in the gravity feels or undergoes gravitational acceleration. Right? Under gravity it has gravitational acceleration. So I hope that idea is clear. Any questions? Okay. Online students? Online students? Okay. With the red pen again, mention the next asterisk mark. With the red pen again, mention the next asterisk mark. Any object travels under gravity. 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 Feels what? Feels gravitational acceleration. Feels gravitational acceleration irrespective of feels gravitational acceleration irrespective of feels gravitational acceleration irrespective of its initial velocity. 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 Irrespective. Irrespective means doesn't depend. Irrespective. Right? Okay. We are moving on. Go to the next question. And there's a small typo with the third question. Make this correction in the route. Make this correction in the route. A ball is released under gravity. What's the ratio among distances covered within its first put a comma, second and third seconds of motion. First, second and third seconds of motion. No? First second, second second, and third second. Okay, first have a diagram. First have a diagram and start. So start it, start working on the question. Start working on the question. A ball is released under gravity at rest. Right? Same scenario. Question 3. Question 3. Same scenario, it is going to be released under something like this. Going to be released under gravity. Right? Then Q equals 0. Right? Q equals 0. Let's say this is point A. This is my T equals 0. And it is moving downwards like this. It is moving downwards. Right? It is moving downwards. And the question is about the distances covered, ratio among distances covered within its first second, second second, and third second of the motion. Right? First second is from T equals 0 to T equals 1. So this is the first second of the motion. 1 second. This is the first second of the motion. Right? And from T equals 1 to T equals 2 seconds, this is the second second of the motion. Right? Second second of the motion. And from T equals 2 to T equals 3 seconds, this is the third second of the motion. Right? That is it, third second of the motion. Right? So it is moving downwards under gravity. So it undergoes gravitational acceleration throughout the motion. It undergoes gravitational acceleration. Right? For my identification, I label this as A, B, C, D. Okay, give it a try. Give it a try. Give it a try. Now identify the distances I have asked. Distance is what's the ratio among distances covered within 3 seconds. So which means the distance covered during 1 second is this. Distance covered during 1 second is this. Right? Let's say SAB. This is the distance covered during the 1 second. Right? Distance covered during the second of motion is this from B to C. The distance covered during the second of motion is this from C to D. I'm asking about that ratio of these three distances, right? Motion starts from here, now ends at here, right? But question is about the distances covered during each second. So therefore, I have split this to each second. This is the first second. So the distance covered during the first second is from A to B. Right? Distance covered during the second of motion is from B to C, SBC. And distance covered from during the third second of motion is from C to D, CD. Now, when you apply equations, make sure, repeating again, make sure directions and sections are mentioned. Now, this is a question with multiple sections. Now, in previous two questions, we had only one section. Now, here we have 1, 2, 3 sections basically. Right? So, this is a question with multiple sections. Your application should be proper. Your application should be proper. Proper in the sense, you have to do the correct thing. You have to apply the correct thing. You have to do the correct thing. Sorry? The ratio is asked. Read the question. It's about the ratio. Ratio of these three is asked. Right? We have to find all three amount, SAB, SBC, and SCD to get the ratio. Ratio is something like this. 1 to 2 to 3. 1 to 1 to 1. So this is called ratio. So we need the ratio among these three. This is called ratio. Feel free to ask any question if you have anything, especially online students. Whether you are on Zoom or YouTube, that doesn't matter. I can see both boxes. You can ask any question if needed. If there's anything to be clarified, ask questions. Time is the time duration. B to C, no? Then in your section, first point is B, final point is C. Okay? Then time is, if you need to get the time interval, final time minus initial time. That's all. But if you are applying from B to C, initial velocity should be the velocity at B. Because for the section of B to C, initial point is B, not A. So then that is not 0. That's what I'm saying. That is not 0. Because velocity at 0 at A only. Now you are applying from B to C. Now for this section, your initial point is B. Initial point of B C section is B. Then velocity at B is not 0. It is unknown. Unknown yet. If needed, we can find out. Unknown yet, that is not 0. Likewise, with that section, it changes. Initial velocity is at here. But if you consider a different section, then initial and final points changes according to section. Now listen, as an example, right? Now that is why actually this question is given. Now as an example, if you are thinking of applying an equation from B to C, if you are thinking of applying an equation from B to C, right? For this particular section, initial point is B, final point is C. Right? But it changes section wise. That's why we are mentioning the section. It changes section wise. If you are considering from A to B, initial point is A, final point is B. If you are considering B to C, initial point becomes B, the final point becomes C. So likewise, with respect to the section you are selecting, it changes. Huh? With respect to the section you are selecting, it changes. Equation can be applied to the section. Initial velocity for PNC, yes. Now, that's a good question. Yes, that is what I mean you to understand. Final velocity at section AB becomes the initial velocity for section B. Yeah? Final velocity of section AB is that there. Final velocity of section AB becomes initial velocity for section BC. Likewise, it changes section wise. Now, when I split this to four, from A to B, if you consider, B becomes four. Then velocity at the final point is the velocity at B. If you consider a section like B to C, B becomes the initial point. Then that same final velocity of AB section becomes the initial velocity of BC section. Right? At where? B? Not given. If needed, you can find. What about time? Time is given. No? 0, 1, 2, 3. You are asking from B to C. From B to C if needed. Now, always, all these things are with respect to the section. All the things are with respect to the section. Now, if your section is B to C, I mean, section is final time minus initial time. Section is from B to C. No? Final time is C equals to, initial time is C equals 1, time duration is 1 second. Time duration is 1 second. Always time means time interval. Time interval, time duration. Time means the time interval. Time interval. Otherwise, that is not the current time. That is the time interval. Give it a try. Right? Choosing a section, selecting a section is something up to us. Now, with that section, all your parameters, all your variables changes. No? Any answers? Any answers before I start the discussion? Correct. Now get the ratio. Good. Okay. Good. Very good. Good. Correct. Good. How about you? Correct. 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 Yeah. Yeah, I can see some of you have got correct answers. Very good. Online students, how about you? Very good. Online students, what about you? If you have got any answers, put them to the chat box. Put them to the chat box if you have got any answers. Correct. Okay, we'll start. I'll start. Okay, any answers from online students? So I didn't receive any answers from the online students yet. So can you increase the quality of sound? Let me check. Let me check. Okay. What about now? Dam? Dam, what about now? Can I respond again to check whether it works? I'll check the sound from my end again as well. And can you confirm from your end? Right. Okay. Okay, let's see. Let's see. Now, my final target is this. What about my final target is this. I need the ratio of these three now. SAB to SBC to SCD. My final target is this. I need the ratio among these three. Right? That is my final target. That is my final target. Right? Now, initial velocity is given. Initial velocity is the velocity at A is known. As I told you, if you are applying to a different section other than A, from A to B or A to C or A to B, that doesn't matter because if you are considering A to C, no, there is a section that has a section, right? Your initial point is still A, then still velocity at A is known. But if you are choosing a different section, like BC or CD, now initial points and final points are going to be changed accordingly. Right? 1, 3, 5. Yeah, right, good. So what about that sound thing you mentioned? Is it fine now? Right? Now, I'm going to do something like this. I'm going to do something like this. First, I'm going to get SAB by using an equation from A to B. From A to B, this is my section. From A to B, I'm going to use S equals UD plus half AD squared vertically downwards. S equals UD plus half AD squared vertically downwards. Right? Then from A to B, it measures SAB. Right? It measures SAB. And U is 0 now because my section is from A to B. Right? Plus half G n T squared is 1 square. Simplify this. SAB is 5 meters. SAB is 5 meters. So I have obtained one term here that is relevant to my final answer. SAB. SAB is 5 meters. Right? And as the second thing, I'm going to think a bit different and going to do something like this. Look at here. Right? Look at here. I'm going to think a bit different and going to do something like this. I'm going to apply an equation from A to C at once. Right? Because my idea is to exclude the velocity term I'm getting at B because that is unknown. That is unknown. I don't know what the value is. Right? So therefore, what I see is I'm going to apply an equation from A to C at once. And then I can get the total distance from all the way from A to C at once. Right? Look at here. Selecting section is my freedom. Right? Okay, thank you. Selecting the section is my thing. That is my freedom. So I'm going to select the section from A to C. But here, from A to C, my idea is this. If I'm going to use an equation from B to C, first I need to determine the velocity at B. Then I have to use another equation now. Right? Then I have to use another equation. One more equation. One more in the sense, now if I need BCD, I have to use 3 more equations. Right? So therefore, excluding that, I'm going to consider the total section from C. And doing the same. Look at here. Doing the same. S equals UD plus half AD squared. S equals UD plus half AD squared. Right? Now it measures all the way from A to C. And that is according to my labeling, that is SAB plus SBC. Is that clear? All the distance from here to here is SAB plus SBC. Right? So that is SAB plus SBC. The total distance. Total distance. Right? Or else, let's go this way. Anything is possible. Right? From here to here, I'll assume this displacement as S2. S2. Right? So S2 equals U is still 0 because my section is from A to 0 plus half G is 10. E now is from A to C. From 0 to T equals to 2 seconds. 2 seconds. 2 square. Right? Simplify this. Simplify this. 5 times 4, 20 meters. 20 meters. So 20 meters is all the way from A to 0. Therefore, SBC is, look at here, this is my argument. Therefore, SBC is 20 minus SAB. Right? SAB is known, 5 meters. So that is 20 minus 5, which means 15 meters. 20 minus 5, that is 15 meters. Right? Similarly, next I am going to apply from A to D. From A to D. Right? A to D, downwards, same equation, S equals UD plus half AD squared. So it measures the total distance from all the way from A to D. So let's say that as S3, It measures the total distance from S3, from A to D. So S3, 0 plus half 10. Now the time consumed is, time interval is 3. So that is 3 square. Simplify this. 5 times 9, 45 meters. 45 meters. Right? So which means now if I need SCD, right? If S3 minus S2 is considered, that is SCD, right? Therefore, SCD is S3 minus S2. S3 is 45. S2 is 20. So that is 25 meters. So that is 25 meters. Right? Now my final answer is this. SAB to SBC to SCD. SAB is known, SBC is known, SCD is known. Right? So SAB is 5 to SBC is 15 to STD is 25. So this is the ratio. This is the ratio, and this is simplifiable. Simplifiable 5 times 3 times 5. So the final answer is 1 to 5 to, sorry, 1 to 3 to 1 to 3 to 5. Final answer 1 to 3 to 5. Now I saw that you have tried using different methods. Very good. Very good. That is how you should think. Very good. You can try this using any method. That is totally fine. That is totally fine. But what I did was a different thing, because now to skip these unwanted velocities. There is anyway an unwanted velocity at the end of the day. No? At the end of the day, we need this. What I'm interested on is displacement. Right? Therefore, now if I'm to find these velocities and do this, at least I need to apply 6 equations. At least 6 equations. Now here, only 3 equations. Right? So this is actually the shortest way of doing this. This is actually the shortest way of doing this. Shortest way. This is actually the shortest way of doing this. Otherwise, this is not the only way of doing this. This is the shortest way. Right? So it's very good that you have tried different methods. It's very good. You have tried different methods when you are trying the question. Right? Or if you have any changes, or if you have done in a different method as an alternative method, take this down. This is actually the shortest method here. Now, even if you have done the question in a different method as an alternative method, you can take this down as an alternative method. And don't hesitate to ask if you have any kind of a question. Don't hesitate to ask if you have any kind of a question. Right? You can ask anything if you have. Yeah. And another important announcement. That is now last week we finished measurements of unit 1. We have finished measurements last week. So therefore, I'll be conducting an extra class to discuss MCQs on measurements, right? And that will be an online one. There will be an online one. Most probably it will be on Saturday at 7 p.m. and only on YouTube, right? Only on YouTube. That's a free session. Free session. And the idea is to discuss questions from units, dimensions, and measuring instruments, as it covers entire unit 1, right? So, what's your availability on not Thursday, on Saturday 7 p.m. What's your availability on Saturday 7 p.m.? You? Saturday 7 p.m. 7 p.m. You? No problem. Online students? Online students? Online students? So you can join that live session and finish it then and there. Otherwise, don't keep these things or procrastinate these things to next week, and then you will miss that. Now, if you miss this week, again you are going to miss the next week as well. So likewise, you are going to keep missing, and finally you are going to stay up with a whole bulk of a pile of work remaining, right? So therefore, if there's a live class, stay in the live class, and if there is 3 hours, just 3 hours, and then it's done. Likewise, you can manage the things easily, right? Which one? I'm not sure about the time. The time is actually the time we can finish all questions. Only MCQs, and it covers entire unit 1, right? It covers entire unit 1. Entire unit 1 means units, dimensions, and measuring instruments. So go through everything and get ready. Go through everything and get ready for that MCQ discussion. Enjoy, right? Huh? This Saturday. This. Right? I didn't fix the date yet because I wanted to check with yours. That's why. Otherwise, I shared a flyer in the group. Did you see? Did you see? I shared a flyer without a date in the group. Sometimes you might have seen it as an MCQ discussion. On Monday, I have shared it. Right? So I'm referring to this. If you are not in the news runs, if you are not in the groups yet, you can join to any of the groups or channels, right? So you can get all updates. Are you in the community? For community, I won't be putting the personal physics ones. Now, this is a physics one, no? So therefore, it will be only on the physics group, right? In community, that is for like all 3 subjects. Now, if it is something personal to physics or something related only for physics, I'll be putting in the group only. That's the thing, right? So I'm referring to this. I'm referring to this, right? So then it will be on Saturday, this Saturday at 7 p.m. and listen again. From your side, what I want you to do is you have to go through everything and be ready for that session. Right? That is not going to be that is don't take it as just a discussion. You need to try it and come there, because I'll be putting the questions that I'm going to discuss maybe before 1.5 hours, 2 hours of time. Then you have some time to try the questions. So you can try it and come to the discussion to check your answers. That will be better, because once you have tried, you know. Now, let's say your answer is wrong, then exactly you know at which point you went wrong. Otherwise, if you just listen to my explanation, you will understand it. But you won't understand the mistakes, right? Probable mistakes you are going to make, right? So therefore, we'll do that way. I'll be sharing you the questions that I'm going to discuss maybe around 2 hours before the session. Then you have enough time to try those questions, right? So after trying all questions, come to the discussion, right? Then you can mark corrections while understanding the points you have went wrong, and if there are different methods or easier methods of doing the same, those things and everything, then that's a better approach to master a skill. Then you will master those skills. So that is how it should be. That is the best way or the better way of learning, right? So I'll be fixing the date today now. So this will be on that will be on this Saturday, 7 p.m. Right? So please join to the live session. And now if there is 2.5 hours or 3 hours or whatever it is, at that time, you can make sure that all types of MCQs that you need to know from Unit 1 is done. That's the idea. That's the whole idea. That's the whole purpose behind that. Okay. Right. Use a red pen and write down below the question. Use a red pen and write down. Use a red pen and write down. Multiple sections, multiple sections, multiple sections, multiple sections can be considered at once. Multiple sections can be considered at once. Multiple sections can be considered at once if acceleration remains constant. If acceleration remains constant, if acceleration remains constant, if acceleration remains constant in each section, if acceleration remains constant in each section, right? So if accelerations are different, we can't do this because in our equations we have only one acceleration term. Now, if there are two accelerations in two different sections, we can't plug the value. So which means we can't use. Therefore, if the accelerations are different, we can't do this. If accelerations are common, multiple sections can be considered, right? So acceleration is critical here in this motion, right? Now this is the impact. Huh? Now if something is falling under gravity, from second to second, the distance increases 5, 15, 45. So it goes like 1, 3, 5, 7, 9. So likewise, it increases. What's the reason? Reason is the impact of gravitational acceleration. Because that is not moving with a uniform velocity. That is always accelerating. Otherwise, if that was a uniform velocity, these distances covered during each second should be same. Here that is not going to be same. Now, if you do this calculation for 2, 3 more seconds, you can see the impact. Now, still in the third second, the displacement is 25 meters. So, considerable amount. What I have done is just releasing an object from rest. Nothing. Without applying any initial velocity. Right? Just releasing an object from rest like this. So, if it falls for 3 seconds, the idea is it falls 45 meters during 3 seconds. It falls 45 meters during 3 seconds. So that's impact. That's the power of gravitational acceleration. That's the impact of gravitational acceleration. Right? Even if we fall, right? Mass doesn't matter. Now, for these things, mass doesn't matter. Even if we fall, we will feel the same. Even for us also, these numbers are same. Exactly the same. Okay, you have something? It changes about 300 meters when we go above the sphere of the what we call that air hemisphere, has a boundary. But all these calculations are done in the surface, no? So that is why it remains same. Right? Now, if we move towards space, right now, if you think further, if we move towards space, that is true gravitational acceleration decreases. And that decreasing starts after around 300 meters of height. So all our calculations here are less than 300 meters. So no problem. Otherwise, if we are on the space, it changes. Right? So you have a different unit for that called gravitational fields. So there we will be calculating gravitational accelerations uh, on Earth, above Earth, at Moon, other planets, in between planets, everywhere. Right? For mechanics, it doesn't matter because that is just low altitude questions, low altitudes. Right? Okay. And next point, mention using a red pen, mention distances covered during each second, distances covered during each second, distances covered during each second, distances covered during each second increases, each second increases from second to second, increases from second to second, increases from second to second because 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 the object travels with gravitational acceleration, because the object travels with gravitational acceleration, because the object travels with gravitational acceleration. Right? Okay. So let's move on. Let's move on. Go to question 4. Go to question 4. Right? Go to question 4. Go to question 4. So first you can have the diagram and then start the question. Finish. Finish. Fourth question. Right, right. Are you are reading the question here? A bus starts its motion at rest from bus stop A and travels with uniform acceleration of 5 ms minus 2 for 6 seconds. Now it travels with uniform velocity for another 4 seconds. At this point, brakes are applied in order to stop the bus at next bus stop B, which is 100 meters away. Right? A hint is given. Hint is uniform velocity means acceleration is 0. Right? Uniform velocity means moving with the uniform velocity means there is no acceleration. Right? No change of velocity. Okay, there are few questions asked. Determine the maximum velocity gained by the bus. Travel distance in uniform velocity. Find the deceleration of the bus. What's the distance between two bus stops A and B? Right. So first start from the sketch. First thing is have a sketch. The bus starts motion at rest from bus stop A. So I'll also help you out with the sketch. Right? The bus starts motion at rest from bus stop A. No? Now A is given. A is given. So let's assume this as A. So this is T equals 0. The bus starts from rest. U equals 0. The bus starts from rest. U equals 0. And travels with uniform acceleration for 6 seconds. Right? Then up to somewhere here, when t equals 6 seconds, it travels with a uniform acceleration of 5. Then from here to here, acceleration of the bus is 5 ms minus 2. Right? From here to here. And then it moves with a, it travels with uniform velocity for another 4 seconds. Another 4 seconds. Then another 4 seconds means t equals 10 seconds here. Right? It moves with a uniform velocity. Now we don't know the velocity gained at this point. We don't know the velocity gained at this point. So let's assume it as v. So if there is v, section is uniform velocity. So end velocity of the same section should also be v. Section is moving with a uniform velocity. No? At this point, brakes are applied. Okay. At this point, brakes are applied. In order to stop the bus at next bus stop B, which is 100 meters away, which means this is B, and that is 100 meters away from this. 100 meters away, right? To stop the bus at B, no. If a bus is stopped, what about the velocity of the bus? At the stopping point, what about the velocity? 0, right? Then from here to 0, velocity decreases. If there is a decrease of velocity, that is actually a deceleration. There is a deceleration, not an acceleration. There is a deceleration. So from here to here, there is a deceleration. So I will mark that deceleration as A. But since there is a deceleration, you will get that with the minus sign, right? I mean, once you find the answer, you will get a minus value for this because decelerations are opposite accelerations. So here final velocity, let's say v dash is going to be 0 because the bus is going to be stopped at B, right? Now to identify the sections, now AB is given already, right? So I'm going to use some other terms, let's say C and D. Right? Now, without looking at the question again and again, now I can explain everything. What happens to this bus from start to the end? That's the purpose of this sketch. Right? Don't try to go through the question again and again. Don't try to go through the question again and again. Right? The sketch. Take it to the sketch at once while you are reading the question, and hereafter you can refer this and try all the questions, try all the parts. Okay, try it. Yes. It will be A to A to C 6 seconds. C to D 4 seconds. T equals 6 to T equals 10. Not given. We don't know. The final time we don't know. So let's say T equals T. We don't know. Not given, no? Not given. Not given. Is it given? No, right? No, is it? That is not given. So we don't know. T equals T. Not given. Time in all linear motion equations are time interval. That is not just a time. That is a time interval. That is a time interval. Right? Right, right. because acceleration is change of rate of change of velocity, right? Uniform velocity means there is no change of velocity because uniform means it remains constant, no change. So since there is no change, if there is a uniform velocity, acceleration becomes zero, no acceleration. This is accelerated from here to here only. There is only the uniform velocity. No, uniform velocity zero, zero. Same velocity, same velocity, velocity and speed. No difference. This is what happens when moving with the uniform velocity. Acceleration is delta v over t. There is a uniform velocity. Delta v is the change of velocity. No? There is a uniform velocity. There is no change of velocity. No change. Because final velocity is also v, initial velocity is also v. So that is going to be zero. So therefore, acceleration is zero when an object moves with a uniform velocity. Right? Right? And you can put your answers in chat box if you have got any answers. Yes. Yeah. So likewise, yeah, good. You have to think and you have to first find out where that maximum velocity occurs. And you have to find that out. Yes, yes. So likewise, now observe the motion. Observe this motion, the behavior of the motion, and then see where the maximum velocity occurs. That is what I'm asking. Asking the value. Right? First, you have to know where at which point that maximum velocity occurs. No? So then observe the motion from start to the end, and then you will see where the maximum velocity is. So that is one thing that you need to do. That is something you need to think. A small thinking. Okay. Yes. Sorry. Uh, yes. Correct. Yes. Correct. Sorry. Deceleration is also an acceleration. Decelerations are negative acceleration. Yeah. Same. Decelerations are negative accelerations. There are no other equations. Same equation, but you will get decelerations with a negative sign, negative value, negative sign as a negative sign. That's the indication of that is a deceleration. That's the indication. Any answers? Second part. Correct. Mention the section and the direction. When you apply equations, everything I explained from the beginning are valid throughout, right? So mention the section. That is why we have labeled these sections. Mention the section with the direction, right? Online students, any answers? Different sections. So mention your section that you are using the equation. Different sections, different sections. Yes, it says it's applied at that point, no? That is given in the question. Yes. Run is different, right? Travel distance in uniform velocity. Now, in which section it travels from uniform velocity, right? Is it zero d? Zero d? There is no acceleration from zero d. Huh? And no acceleration as well. From zero d, there is moving with the uniform velocity, right? No acceleration. And this is correct. This is wrong because 30 ms minus 1 and 120 meters. Okay. Okay, let's start. First one. First one. Determine the maximum velocity gained by the bus. First, study this motion, study this behavior of the motion, and first thing is you have to identify where the maximum velocity occurs, at which point the maximum velocity occurs. Right? Look at the board. Okay, look at here. So it starts from the bus starts from rest that is given, right? And from A to Z, it accelerates with 5 ms minus 2, right? Accelerates. And C to D, it moves with a uniform velocity. Uniform velocity means there is no acceleration. So whatever the velocity it has gained at this point will be continuing up until D, right? And at D, brakes are applied. At D, brakes are applied. So which means after this point, velocity decreases to zero because it is going to stop at B. It will be decreased to zero. So from here to here, from D to B, since there is a decreasing velocity, there is a deceleration. Right? So simply A to C motion is an acceleration. And at C, it has gained whatever the velocity, it has gained whatever the maximum velocity. It has gained because there is the end point of acceleration. There is the end point of acceleration, there is no more increase for the velocity, no. This is the end point of acceleration. So my first observation is maximum velocity is reached at C. And that same maximum velocity is continued until D. It is same. And after D to B, there is decreasing velocity. So therefore, first question is about maximum velocity. My first identification is maximum velocity occurs at C. Maximum velocity occurs at C. Right? So this is my first identification. Since maximum velocity occurs C, since maximum velocity occurs at C, right? From A to Z, we can use an equation now. From A to C, from A to C, A to Z, time is known, acceleration is known, initial velocity is known. Right? So which means we can use V equals U plus AT. V is V, U is 0, and acceleration is to the same direction 5, and time is from t equals 0 to t equals 6, time duration 6 seconds. Right? 30 ms minus 1. So maximum velocity gain by the object is 30. 30 ms minus 1. Right? Good. You also good. Right? And make sure that you have mentioned the section and the direction. Yes. Right? Say down first one 30 ms minus 1. Velocity at C is 30 and that 30 is uniform until D. That remains uniform until D. Right? Okay, part 2. Part 2. Travel distance in uniform velocity. Travel distance in uniform velocity. Uniform velocity occurs from C to D, no? Right? Uniform velocity occurs from C to D. And if I need the travel distance in uniform velocity, which means I need this, the distance between C and D. Right? So let's say C to D, SCD. Right? Part 2. We need the distance from C to D. Apply an equation from C to D. Right? Now velocity at C is known. Velocity at D is also known. Right? And time is also known. Right? I'm going to use from C to D rightwards. I'm going to use SC equals UD plus half AD square. Right? SC is S from C to D is SCD. And U for CD section is V. V is 30. Right? 30 time duration 10 to 6 to 10 4 seconds plus here half times no acceleration because it moves with uniform velocity. Right? This entire part becomes 0. Right? This entire thing becomes 0 since acceleration equals 0. Right? So CD equals 120 meters. 120 meters. Should you mention? No, that is for the identification now. CD is for my identification. Because now if I need another displacement to be determined, let's say from A to C, then I can't write it as S again because I have already used S. So that's why I'm using SACD, SCD. Then just by looking at this, I know this is from where to where, which point to which point. Right? Otherwise, if needed, you can use S1, S2, S3 or something else. That's fine. Or even X, Y, anything. Any unknown variable is fine. Right? But when it is mentioned in this way, that is very easy to identify. Right? Otherwise, if I mention it as X, now again I have to keep in mind what X is. Now here I know just by looking at this at a glance I know SCD is the displacement from C to D. That's the purpose behind that. Otherwise, that is not a rule. There is no such rule like that. That is just for the ease of identification. Just for the ease of identification. Right? Next one. Find the deceleration of the bus. Find the deceleration of the bus. Part 3. Find the deceleration of the bus. Right. If brakes are applied at D, and if the bus stops at D, from D to D, in this section, the bus has a deceleration. Right? The bus has a deceleration. Right? Now, even though if we know that as a deceleration, right? Decelerations are negative accelerations. We don't use the negative sign for the term which we are going to determine. We will let it come. Then once that comes, we can verify whether it's a deceleration or acceleration just by looking at the sign. So therefore, even if we know that as a deceleration, now for sure I know that is a deceleration. But don't plug the value, don't plug the sign. Right? Don't plug the sign. Let it come. If you plug the sign, you will get it as a plus value. Then you don't have any indication whether it's a deceleration or an acceleration. Right? Therefore, don't plug the sign. Let it come. Now, always for the determining physical quantity, the magnitude comes along with the sign. That is how vectors work. Right? Magnitude comes along with the sign. When a positive sign comes, we don't write sign usually. By default, this numbers means positive numbers, no? Right? Okay, then from D to B. This is from D to B. From D to B, horizontally rightwards, time is known, final velocity is known, initial velocity is also known, right? And time is unknown, displacement is known instead. So we can use an equation like V squared equals Q squared plus 2AS, right? V squared is v dash squared. V dash squared. U squared is v squared because my initial point now is the velocity at d, right? That is d squared plus 2a s. S is actually from d to v, right? Now I'll plug the values. 0 squared is 0. V squared is, what was the value? 30. 30 squared plus 2a times s from d to b is 100. S from d to b is 100, right? So we can take this to the other side and simplify. This is minus 2a times 100 equals 30 squared is 30 times 30. Don't simplify it as 900 because anyway it's going to cancel, right? Don't simplify it as 900. Let it cancel. This 0 to 0 to these two cancels, right? So minus 2a equals 9. A equals minus 9 over 2, which means A is minus 4.5 ms minus 2. 4.5 ms minus 2. A is minus 4.5 ms minus 2. Right? So the minus sign is the indication or the verification that it is a deceleration. It is a deceleration. Right? So likewise, let it come. Let that minus sign come. In the question, it is asked as a deceleration. Right? So deceleration is this minus 4.5. Now, if you are writing this as a deceleration, even if you write this without the minus sign, that doesn't matter because we know that as a deceleration. But in the calculation, don't plug minus sign here. Let it come. Clear? Yes. No, this is not a must write line. This is for your reference. Right? Doesn't matter. Right. Next one. What's the distance between two bus stops A and B? Right. Distance between two bus stops A and B. Now, two distances are already known. SCD is determined before 120, and SD to B is known 100. Now, if I determine the distance from A to B, right, I can add them up together and get the distance from A to B, right? Therefore, for the fourth one, part 4, now you can use any of the equations to get the distance, displacement actually from A to C, right? From A to C. Then use an equation like from A to C, something like S equals ut plus half AD squared. S is S from A to C. U is 0. This part becomes 0. Half acceleration is 5. D squared is 6 squared. Simplify this. S equals 90, right? 90 meters. 90 meters. That is just AC. What is asked is the distance from A to B. What's the distance between two bus stops A and B, right? What? Right. Okay, online students, any questions? Write down before I raise. Right? The distance from A to B is therefore SAB, distance from A to B is Between A and Z, we have 90 meters, right? And C and D, 120 meters, plus, we write here, plus between D and B, 100 meters. So SAD equals, sorry, 120, 310. 310 meters. The final answer, 310 meters. Right, 310 meters. Good. Now, when there are multiple options now to determine these distances, you can use any of the equations actually. Right? When there are multiple options, you can go with your own preferred equation. That's fine. Right? So make sure you have mentioned the section and the direction properly with the relevant equation. Right? Answers would be the same. Right? If your answers are different, that is definitely an incorrect, improper application. Right? Okay, make the corrections quickly. Make the corrections. Good. Okay, online students, any questions? Any questions, online students? Good. Right. All clear. Right. Good. Okay. Now listen. All right. So today we started linear motion and introduced linear motion equations, and identified parameters. And after that, now here we are, and we tried 4 questions, right? 4. So we tried 4 example questions, right? 4 example applications of linear motion equations, right? And this is not the end. We are still in the first phase of linear motion questions, right? The first phase, right? Now, if you understood everything today, so your foundation is perfect. If you understood everything today, the foundation for linear motion is perfect. This is not the end. Now we are not even in the middle, right? We are just still in the first phase of linear motion, right? And we started with the simplest questions. Now we are still in kind of not even average, kind of simple questions, right? So next day plan is first we will be moving towards the other advanced questions in linear motion, right? And the next part, the next significant part coming up is linear motion variations, motion graphs, motion variations, right? And after variations are done, you will be doing the same using the graph as well, which means now today what we did was using equations. So we did everything using linear motion equations. But if we have linear motion graph, using the graph also, we can do the same. We can solve questions, right? So those are the parts coming up. So next day, the first thing is first we will finish all questions from linear motion equations, right? And then we are moving towards linear motion graphs, right? In linear motion graphs, you have to plot graph and convert graphs, right? Among all 3 types of graph, like displacement time, velocity time, and acceleration time. And then we will practice more questions based on the graph as well, right? Based on the graph. And when it comes to essay questions you are getting in mechanics, usually if the question is coming from linear motion, typically velocity time or acceleration time or any motion time graph are included. That is how it is, right? Because you are going to get a question for 30 marks as they say, right? So therefore, it consists of several things, and the entire 30 marks is not going to uh, be for linear motion, just for linear motion. For mechanics, that's 30 marks. For linear motion, if a linear motion part comes, it will be around 15 marks, right? That's also a significant, a considerable amount of marks, right? So therefore, the rest of the parts coming up are those things. Now, repeating again. Now, if you understood everything today, which means now you have got all basics of linear motion properly. All the basics, right? It doesn't mean that your linear motion is finished. No, right? We just started, right? So therefore, in the next class, that's the plan. So we'll be first doing the advanced questions on this, and then the next part we are starting is linear motion graphs, right? Linear motion graphs, right? Any other questions? Any other questions before wrapping up? All good. Online students. Online students. Any questions before wrapping up? Didn't receive the dude. Yeah, you will get it sooner, by today or tomorrow. You get it, right? Yeah, don't worry. There will be a probable delay because of the in between power day we had, right? Any other questions? Right. Okay then. So then, if I process the class, no, it's already posted. No, it's already posted. Right? That may be because of that power day. Right. So then, we'll wrap up the session here. So don't miss the next class because there we'll be discussing the remaining questions, the rest of the questions of linear motion here, and starting linear motion graphs, right? And by next day we are going to finish linear motion, right? And the next plan in mechanics is after linear motion we are starting projectile motion, right? So there are more things coming up, right? Okay then. All right, so I'll wrap up the session here. Right? Study hard, work hard, go safe, and goodbye. All right.